Okay. Hi everyone. I'm Adriano Rizzi. I am an agronomist. I work in Rizobacter since 2018, and I am the technical leader responsible of the international division. I'm in charge of to organize the field trials, also to give support with application of our product, and also make the new protocols for our new technologies. First of all, I want to thank the organization to invite us. Thanks, and it's very important for us to participate in this important symposium. Something about our company has been growing for the past 45 years. We started an inoculant company, a local inoculant company in Argentina. But today we are a global corporation that we have 8 subsidiaries, and one of them is here in South Africa, in Pretoria. And also 12 years ago, we started our presence here in South Africa with our partner, MBFI, a very important company in the soybean crop in general. And today we are very happy to be the leaders in the inoculant soybean segment. We have an estimated turnover the next fiscal year of $293 million. We use a lot of around 13% of this balance to research. We have the 23% of the soybean inoculant market around the world, and we have a team with more than 6,500 of people. Talking about biological nitrogen fixation, we will talk. I will talk about the Rhizobia applications and why are we using Rhizobia. With the application of Rhizobia, with the inoculating process, we are looking and improving the natural capacity that the legumes and the Rhizobia has when they work together, which is the biological nitrogen fixation. It's a symbiotic relationship. Rhizobia receives photoassimilates from the photosynthesis from the plant, and the legume receives nitrogen that is providing for the Rhizobia that eats in the nodules in the roots. With this cultural application, we can complete the 18% of all the requirements of nitrogen of the soybean, and the plant can have nitrogen from the atmosphere with this process, with the biological nitrogen fixation. And also it's complementary the amount of nitrogen that the soil has. So it's key in legumes to maximize this biological nitrogen fixation, and I think that soybean crop can get also the nitrogen from the soil, but for an economic and an environmental reason, it's the inoculant and the Rhizobia have much more sense. Okay, when we talk about what is an inoculant, it's an advanced industrially developed biopreparation that contains Rhizobia previously selected for their ability and effectiveness to fix nitrogen. In Rizobacter, we really specialize in this. Our know-how it's in culture media, fermentation, formulation, and packaging, all the stages to make an inoculant. And for the strains, we use the strains that are provided for institutions or universities. In all these different steps or components, we can innovate and generate new products. This is a really good image about worldwide how is the soybean inoculation adopted. Here we can see that not all the areas have the same adoption. You will be happy to see that South Africa have a really, it's one of the countries that inoculant is very popular, like South America and some parts of Europe. And in this picture, also it's important to mention that you can see that the United States, one of the first of the principal producers of soybean, they don't have the same adoption of the inoculation. Maybe you ask if you are doing well the things inoculating, but I can say that yes, because inoculation response depends a lot of the environmental things of the different soils of the different countries. So in United States we have really good soils, and they can you can inoculate, and the Rhizobia naturalize and lives a lot of years. So maybe farmers inoculate on 1 year, and in another year they don't inoculate. And also they plant a lot of corn. They have a really a rotation. So it's crop, it's corn, soybean. So they have a really important levels of nitrogen. So this is why also they don't use inoculant when they out with a soybean on a corn crop. The innovation areas that we work or in which areas that we can innovate are a lot. First, we have the strains. We can get or analyze new strains. Or now it's very new, but also we have the possibility of the strain improvement with the genetical process, and it's a little complicated. Then we can innovate in the inoculant manufacturing. For example, in the culture media, the culture media are the ingredients that we can add in the fermentation process. to make the Rhizobia growth comfortably and rapidly and quickly. The R&D have a very important paper in this area. Then in the fermentation process, we know that a lot of conditions in this process, like temperature, pressure, pH, oxygen concentration, have an effect on the biology of the Rhizobia. We can affect the performance of the Rhizobia in the field. Then we have the formulation. We have to stabilize the Rhizobia to keep them in a comfortable environment and to stay in the packaging and provide the expected shelf life. Then in the packaging, we can do a lot of things, but for us it's important. It's not very important the primary packaging, the labels, the boxes. So it's really important how the materials that we use to contain the Rhizobia, because they need a correct we need a correct exchange of gases, and we need boxes to isolate the bacteria from challenging environmental conditions that it's an unusual problem in the logistic process. Then in terms of inoculant application, we can innovate in different areas. We have specific products for each kind of application. For example, the industrial application or in-farm application. On farm, you can apply on seed, on soil. The most common application on soil around the world is in farrow, but it's not the most adapted application. And then another innovation area that is very important for us is the inoculant partners, that are things that we can add to our Rhizobia to improve the growth of the plant and also the nitrogen fixation. For example, we have a lot of beneficial microbes, and also we combine with micronutrients. The most important micronutrients that we are developing and working are the cobalamin and molybdenum, for example. So we have specific products for a specific application. That is what Rizobacter do. And we can offer inoculant partners, and I will show you works with the most important partners to see some results. This is a really early job that we are doing with the strains. We have an important question here. Here we use the strain, the WB74, comparing to a control strain. You can see here, this is this is concentration on the C, CFU per seed, and this is these two are only the strains without any technology or without any inoculant are in a sterile ambient, and we can see the difference in the response of the strain. But the important here is when we add a technology, for example, this is one of our technology, the top, the osmoprotection technology. We saw that the comportation, no matter which strain, are better if you use alone. So we have this same job, but looking in the total root node dry mass, and we saw the same thing that with the use of technology we have with the use of formulation we have better results, and doesn't matter the strain. So we don't are saying that because we have information about only 2 strains, we are don't saying that it's not important the strain selection, but we are showing that it's more the technology and the formulation have a more important impact. Talking about our technologies, here in South Africa, we have 4 technologies. We have a liquid common inoculant. Then we have all the inoculants that we have here are in liquid suspension. Then we have a Rizolic that is it has a osmoprotection technology. I will explain what is that. Then we have Signum that have another kind, also have the osmoprotection technology, but we add the bioinduction technology. And then we have the Elite that is the long life inoculant technology that it's more orientated to professional seed treatment and industrial treatments. Also, we are adding a new technology that we are in other parts of the world it's already working. It's the HC technology, the high concentration technology, that it's for all these 4 inoculants. We are going to increase the concentration to reduce the rate of these products, because the global 10 is to use use more concentrated inoculants, less rates to can add another products like the micronutrients, another micros, and also some products that are good for the planter performance, like polymers or coatings that have a better move of the seed. Like I say before, one of our technology is the osmoprotection technology. The result of this technology is more strange bacteria. We put these bacteria in the fermentation process with different. We induce stress and a stress process. We vary the temperature, the pressure, and the high osmotic pressure. So the results are strange bacteria and more concentration. The key here is that the bacteria have the capacity of accumulate the principal disease, I don't know, the principal disease aspect, or I don't know in English how it calls, is the dry soils. Here I will show a video that presents our second.
What is bioinduction?
The bioinduction.
What is bioinduction? Bioinduction is a technology.
You listen? No. You're listening? Yeah. Okay.
What is bioinduction? Bioinduction is a technology developed.
That was.
What is bioinduction? Bioinduction is a technology developed by Rizobacter that generates molecular signals to activate metabolic processes in bacteria and plants. This allows for earlier and more efficient nodulation, which maximizes nitrogen fixation capacity and promotes nutrient uptake, resulting in increased legume growth. Bioinduction also stimulates interaction between beneficial microorganisms in the soil. This boosts plant resistance to adverse environmental conditions such as low temperatures, drought, and soil acidity. Bioinduction activates microbial and plant physiology, acts on crop germination and development. Apply statement to ensure that your crop gets every advantage. 23% of growers around the world are already benefiting from Rizobacter inoculants. What are you waiting for?
Okay, that explains a little what is this technology. What we do is in the fermentation tank. This is a conventional manufacturing, and then we have our manufacturing that we add a bioinducer components that they are biochemical signals that are natural produced for the plants that are for the nodules to start the fixation of nitrogen. So what we do here is in the fermentation tank add this kind of biochemical or bioinducer components. So the bacteria, the Rhizobia, also already it's prepared and it's like it's treated and it's already prepared to make the nodulation. So the result of that is early nodulation in the crop. Early nodulation means that the nodules are positioned in the primary root. That is very important because in the primary root is where it's more efficient the nitrogen fixation. For example, 10 nodules of the secondary root are fixed the same of one nodule of the principal root. So when you take a plant and see a lot of nodules in the secondary root, maybe it's not a good inoculation. That is important, and this kind of product is very important to this environmental soils with problems. For example, with pH, with acid pH, and when you have slow temperatures after sowing, for example, or when you are planting in new fields that not have a soybean history. About the application, we produce different inoculants for different equipment necessaries. So from the left to the right, we we improve the scale, the precision, the complexity, the sophistication, and the investment. The first one is the most common way to apply the inoculants. It's an on-farm, the on-farm application. Then we have an intermediate that is more professional, that can be used to slow smallest seed multipliers or producer, or maybe some farmers that have the area to justify the investment. And the third one is it's using for industrial production of industrial inoculation, and it's more for seed companies or seed multipliers that that are offering ready-to-use seed. That is a trend that in the world we can saw that it's really high. Okay, this is, I will pay. Here, it's an example that is useful. For example, here we can see in Brazil that have the really similar conditions from here. They are in the past years. They are increment the participation of the industrial treatment. In these 2 years they have 800,000 of hectares with this seed treatment, and the last year they have 2.4 millions. So it is increasing, and we are in Brazil. We are leaders in this segment, and we are very proud of that. And because it's one of the most challenging market, not only because the scale, because also in terms of environmental conditions for the Rhizobia, something very similar here. And this is a technology that we have here in South Africa. This is a trial that we do to demonstrate that you can have the same, this is another dry mass, you can have the same performance with an inoculant that was used 60 days before planting, 45 days before planting, and 30 days before planting. One is a control. It's an sterile substrate without nitrogen and without inoculant, and the two is liquid inoculant in farm. So we are looking for that we can provide a product that you can use really early and have the same performance that on an on-farm inoculant. There are some images some pictures that illustrate very clear the previously results. This is how look the seed treat on farm and with the industrial treatment. But here the key is have a good distribution of the products in the seed. No matter if it's on farm, because on farm you can do a very good quality application. But in the industrial way, you have a kind of insurance in that. And for more complex seed treatments, for example, if you add more products, it's better to do in the industrial way. This is the same, how it look. We can add some additional coatings, like I say before, and additional polymers that improve the flowability of the seed in the planters. And finally, I will talk about the inoculant partners. We have, like I say before, we have the micronutrients, and then we have the benefits micros. Here it's represented the biological nitrogen fixation. And here it's important to see how molybdenum and cobalamin are really an important part of this process. For example, the molybdenum, it's part of the nitrogen complex. It's responsible to take the gas nitrogen, and to convert in a way, in a nitrogen way, to be useful to the plant. And then we have the legemoglobin, that it's very related with the cobalamin. It's cobalamin. It's a cofactor of this enzyme, and regulates the auxin concentration, and that is very important for the nitrogen fixation. Here we have a work that it's made in Brazil in more than with a lot of trials, and we clearly see how using these two micronutrients with the inoculant have a yield response. The most important here is for us to designate a product with cobalamin and molybdenum that will be with a good compatibility with the inoculant. There are a lot of products with these micronutrients, but they have negative components that affect the Rhizobia leaf. So, for example, the pH, the acidity, and also have some biocides that affect the Rhizobia. So in Rizobacter we develop, and it's in the market. I think that in South Africa will be soon. We make a special formulation of these two micronutrients that we can apply with our inoculants, and we don't have a negative effect. So we can use the advantages of the micronutrients and also the Rhizobia, maintaining, of course, the performance in yield. Another kind of inoculant partners are the microorganisms. For example, Azospirillum is a very important microorganism that we can use with the Rhizobia. It's a micro that also are in the roots and have nitrogen fixation, and also have a PGPR effect. So we saw that we saw really good results with the co-inoculation with Azospirillum. In Brazil, for example, nowadays we have near the 30% of the adoption, and also we have we are the leaders in this market. They also use in another crops, but in legumes works very good. The key here is that the Azospirillum produce a lot of biohormones that induce root develop and more root tips. So if you have more root tips, you will have more nodules, and also we can use better the nutrients and the water. And the final partner that we have, that here in South Africa we work with MBFI, it's the Trichoderma. It's another kind of partner. It's a biocontrol fungus. So we saw that it's a very important co-inoculation too. This is again the Brazil market. 10% of the total crop area are using this co-inoculation, and in this show we can see the effects that have this kind of co-inoculation. You have a really important disease incidence that are reduced in some soils that you see that the soil have some kind of pathogens, but also you have a very positive effect in grain yield, in shoot nitrogen, root mass, nodule member, nodule mass, and this kind of enzyme. So it's not also it's not only a disease controller, so also have these PGPR effects. And when we talk about Fusarium, Rhizoctonia, and others diseases, we can show that this happened with the disease incidence of Rhizoctonia fusarium, have a really good effect, the co-inoculation, and also we have an effect in the grain yield. That is why a farmer can add this technology for their use. So, in conclusions, we think that the biological nitrogen fixation is the most sustainable source of nitrogen. Not all products and formulations are the same. We work on that, and we are producers of this kind of products, so since we also give support to the application of these products with our staff and with the staff of our retailers. Professional industrial inoculant applications are a global trend. Inoculant partners to further enhance biological nitrogen fixation. Innovation, we have a lot of innovation ready for South Africa, and streamline and agile registration process it's needed to us to can bring you the most quickly possible our new technologies. So that's all, and thank you very much. Sorry for my English, and I'm very grateful.